everyone, welcome to Team 101's final project on League of Legends presented by Shuyan Gao, Jim Liu, and William Huang. So League of Legends is one of the world's most popular games with a total of 180 million monthly players in 2022. Among the various factors that influence the win of the game, goal difference has been proved to be a very important factor because it will lead to difference in players' items, which will lead to difference in players' strengths, and that is defining whether you will win this game or lose it. So the goal of our project today is to build a model to identify the strategies that contribute significantly to goal differences. To solve this problem, we apply statistical analysis on League of Legends dataset, which includes 54 predictors in total, and our main response is goal difference.
Before constructing our initial model, we first need to do data cleaning. Remove predictors that only contain values of 0 and game IDs since they're insignificant to our models. Next, we assess predictors that are multicollinear because highly correlated predictors could affect our inferences and cause instability to the model. The color map shows the correlation between two predictors. The darker the color is, the higher the correlation. Predictors with BI of more than 5 usually have a serious collinearity problem. We identify these predictors and remove 4 of them to resolve the issues. We construct our initial model using the algorithm forward selection. After generating a set of models, we use BIC to select the best one. We look for the model with lowest BIC since it indicates that the model is a good fit and also less complex and easier for us to interpret. Next, we present our result of our initial model. We use partial t-tests on each predictor and find each one of them significant. The R-squared below shows a 90.4% of variation in the goal difference explained by our model. Next, we evaluate our model using residual diagnostics. According to the skill location plot, the flat red line indicates that our model follows the constant variance assumption. According to the normal QQ plot, we can see the points follow a straight line, meaning the assumption of normality is satisfied. Although there are some outliers in high leverage points according to the residual spread average plot, it's not too problematic because we have a large data set. The problem with our initial model is that it has too many predictors, which means it's very difficult to interpret the model. Moreover, it will be difficult to calculate goal difference in the game with high amount of input predictors. The algorithm we use may also not guarantee that our model is the best model.
To solve this problem, we decided to use the algorithm of best subset, which is finding the top 4 most significant predictors so that we can actually look deeper into the predictors with the most significance and make predictions. And so for our final model, we found 4 different variables. The first one being is first tower, the second one being lost Baron Nashor, the third one being best, and fourth one being assist. As you can see, all of their p-values are relatively low, which means that they're significant, and here are their estimated coefficients. To evaluate our final model, we first checked multicollinearity, which showed that no significant correlation between predictors. And we also looked at the residual analysis, which showed that the assumptions of constant variance and normalities are satisfied. There are some outliers and high leverage points, however, but because we are having a large data set, the negative impacts of these are mostly mitigated. So for our final model, we see that this is actually a simpler model with a lot less predictors, with all predictors actually easily accessible in game, which makes it very easy to use and to learn from. We also see that our model is valid, and we do recognize that we are sacrificing our R-squared a bit right here. But lower R-squared does not necessarily mean that our model got worse. It just means that the model explains less variability in the response.
And with that being said, we now come to our recommendations. So first tower has the biggest absolute coefficient based on our model, which means that it plays a very influential role in determining the goal differences. Therefore, teams should prioritize in getting the first tower. And teams should also try their best to avoid the enemy team from killing the Baron Nashor. Players should also play safe and avoid getting killed by the enemy, as that result will not only give the enemy goal, but also prevents you from getting the goal. Last but not least, players should participate in team fights and assist their team in getting kills. In conclusion, we have a very simple model that is also statistically significant. And with this model, we hope you can win your next game. And thanks for listening to our final project.